Hello, Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. Okay, so we are still in the subchapter of how to solve second order non-homogeneous linear differential equation with constant coefficient. Okay, so now let's have a look at the following example in which the fx contains of polynomial function. Okay, so what is the question? So the question is find the particular solution for initial value problem y double prime plus 3y prime equal to 1 minus x with initial conditions when x equal to 0, y equal to 1, and when x equal to 0, y prime is equal to 1. Okay, so here you see the keyword here, you need to find the particular solution. Okay, remember, when you need to find the particular solution, so your final answer, you must eliminate all the constant value. Okay, so how to find the constant value? So you need to substitute these two initial conditions. Okay, so the ODE here is the y double prime plus 3y prime equal to 1 minus x with fx is a polynomial. Okay, so step number 1, as usual, you need to find your YC for the corresponding homogeneous equation. Okay, from here, this is your non-homogeneous equation. Okay, so make it homogeneous first by replacing the fx equal to 0. Okay, so your homogeneous equation is equal to y double prime plus 3y prime equal to 0. Okay, from this homogeneous equation, since it is quadratic equation, since this is in terms of quadratic, so you need to come up with your characteristic equation. Okay, the characteristic equation is m squared plus 3m equal to 0. So, you use your calculator, try to find what is the root number for the equation. So, based on my calculator, what I get, m1 is equal to 0, m2 is equal to negative 3. Okay, based on this is considered as a case 1, where your root is a real number and m1 is not equal to m2. So your yx is equal to a exponential m1x plus b exponential m2x. So this is the general solution for the corresponding homogeneous equation. Okay, so from here we have yc is equal to a exponential m1 is equal to 0, so 0x plus b exponential m2 is negative 3x. Okay, so exponential 0, I can simplify it to become 1. So my yc is equal to a plus b exponential negative 3x. Okay, so next, once you have your yc, you need to find your yp. Okay, so we find yp based on type of fx. Okay, so type of x, what is the type of our fx? So our fx is a polynomial type. So you refer to the table that I had provided before. So, when it's polynomial, so it means it belongs to case number 2. So, if you refer to the table, if fx equal to kx, so in this case, k is a negative 1. Okay, so the number 1, you can just eliminate it. So, we just consider negative x. So, k is negative 1. So, I can assume my yp is equal to cx plus d. Okay, so yp is equal to cx plus d. Okay, and then you need to compare this yp to the previous yc. Okay, let's have a look. Here I have d is equal, here I also have a. So I can consider this yp have a same pattern with yp. So we consider it equal to yc, right? Okay, and then once it's the same with the yc, I need to multiply yp with x. So yp is equal to cx squared plus dx. And then you need to compare again with the yc. So cx squared, we don't have any same pattern here. dx also don't have any same pattern here. So we consider yp is not same as a yc. So you may stop here. So this is your final yp that you are going to use throughout the process. Okay. So now your yp is equal to cx squared plus dx. So you need to find what is the value for c and what is the value for d. So how to find it? Okay, you need to differentiate yp 2 times. So my yp prime is equal to, I differentiate cx squared, I got 2cx. I differentiate dx, I got d. And then after that, I differentiate it again. So yp double prime is equal to 2c. I differentiate d, I got 0. Okay? Alright. Okay, so you got your yp double prime and yp prime already. So next, you need to substitute your yp double prime and yp prime into the given ODE. So based on the question, the ODE is given by y double prime plus 3y prime equal to 1 minus x. Okay, so from there, you got yp double prime plus 3yp prime equal to 1 over x. So, and then you substitute your yp double prime is equal to 2c, and then your yp prime is equal to 2cx plus d equal to 1 minus x. Okay, from there, you rearrange your equation so that it follow the coefficient accordingly. So, I rearrange it, become x, 3 minus 2c, I have 6c here, plus 2c plus 3d. Okay, 3 multiplied with d, I got 3d here, 2c plus 3d. Okay, once I rearrange it, I can equating the coefficient. Okay, so for the x to the power of 0, I have 2c plus 3d equal to 1. Okay, so I can solve it at this time. So I leave it first as the equation number 1. Okay, and for x to the power of 1, 6c is equal to negative 1. 6c equal to negative 1. So c is equal to negative 1 over 6. Then after that, I can solve this equation so that my 3d is equal to 1 minus 2c. Okay, so c is negative 1 over 6. So I substitute here, I get 8 over 6. So my d is equal to 8 over 18 or 4 over 9. Okay, so now I have my c and I have my d. I can substitute all these two numbers into the yp. Alright, so your yp is cx squared plus dx. Okay, so c is equal to negative 1 over cx squared. D is equal to 4 over 9x. Okay, so this is my final yp. So this is my particular integral value. Okay, so we go to the next step. Step number 3. You need to find the general solution for the ODE. Y is equal to yc plus yp. So your yc is given by a plus b exponential negative 3x. And then my yp is equal to negative 1 over 6x squared plus 4 over 9x. Okay, so this is my general solution. Okay, remember, in the question, it's asking you find the particular solution. So, from here, you need to find what is the value for A and what is the value for B. How to find this? You need to substitute the initial condition. Okay, now we go to step number 4. Step number 4, consider initial condition. When x equal to 0, y equal to 1. When x equal to 0, y prime equal to 1. Okay, so based on the previous step, from step number 3, your y is equal to a, your general solution is given by y equal to a plus b exponential negative 3x minus 1 over 6x squared plus 4 over 9x. Okay, so you consider your first initial condition. When x equal to 0, y equal to 1. So you substitute accordingly. Y equal to 1, a, b exponential, your x now equal to 0. So b exponential 0 minus 1 over 6x is 0 and x here also 0. So here 0, 0 can be cancelled out. So exponential 0, I got 1. So 1 equal to a plus b. Okay, this is considered as my equation number 1. Okay, so you need to consider the second initial condition. Here you have got y prime. So based on this general solution, you need to differentiate this to get your y prime. So y prime is equal to a, you differentiate, you got 0. So b exponential negative 3x, you differentiate, you got negative 3b exponential negative 3x. So x squared, you differentiate, you got 2x. So negative 2 over 6x. So x, you differentiate, you got 1. So plus 4 over 9. Okay, based on this, from this equation, you can substitute your second initial condition. So when x equal to 0, y prime is equal to 1. So y prime equal to 1 equal to negative 3b exponential 0 minus 2 over 6x0 plus 4 over 9. So this one I can cancel it out because it becomes 0. So exponential 0, I got 1. So negative 3b plus 4 over 9. So I rearrange it accordingly and then try to solve it. Lastly, I got b equal to negative 5 over 27. So substitute this value into this equation. From equation number 1, a plus b equal to 1. So a is 1 plus 5 over 27. And then a, I got 32 over 27. Okay. So, my particular solution, y is equal to, I substitute the value of a and b accordingly. Okay. So, this is my particular solution for the question. Okay. Good luck and thank you for watching.